we have a pipeline that demo the windows. So now let us create some data. We will use some like simple data. That is just the time year of 2021, the full moon. There is actually 13 of them. The timestamp of each full moon. And we run this pipeline actually. Our data is a tuple at the first. The first element of the tuple is the timestamp, and the second is the name of this full moon event. And we have astronomer event transform that first create this data and then use the timestamp value, convert this tuple into a timestamp value. This is basically how the timestamp is labeled associated with each data. With this transform, if we print these values, we only see the value part of the data. We do not see the timestamp. It's not because they are gone, it's because this becomes a metadata or timestamp for each element. If we just print the element, we don't see the timestamp, but it's still associated with the element itself, and the windowing will react on these timestamps. We'll show it later. So we first demo the global window. So all pipeline use global window as default. This is the single window that covers entire option. In many cases, especially in batch pipeline, this is what we want since we want to analyze the data that we have. This is a pipeline we have, and this will print the global window. This print window info will print the window and the timestamp and the element. Now all the data is in the global window. And if you checked out the collab, I can also paste it here. There is a demonstration for the global window. And you will see all the elements belong to the same global window. This is just a visual demonstration of this print window info. Then the fixed time windows. If we want to analyze our data like hourly, daily, monthly, we might want to create event evenly spaced intervals. That's when we use fixed time window. So this pipeline then first will window the incoming elements into fixed windows, which the fixed size and of 3 months per window. That is a quarter. And you will show the window of each element. Here is the January 3rd to April 3rd belong to the same window. And also some element belong to second window, third window, and fourth window. It shows the first has one element. Oh, so this is some new moon and full moon astronomy events. Not all the full moons, sorry. But anyways, this also demonstrate the window size and the element. We can see the elements are distributed into the fixed windows, and each window has the same window size. And then we check the case of session of the sliding windows. Let me also paste the sliding window. Maybe we want to fix that window. We don't want to wait until window finish, so we can start a new one. Then this is a use case. We use sliding window. It's very similar in implementation. It's very similar to fixed window. You also have a window into, and don't use fixed window, just use slide window. The node has two parameters instead of one: window size and window period. Then we print this window. It looks much longer because now each element can belong to multiple windows. For example, this March equinox, it belongs to 3 windows, and starting from January, February, and March, and each lasts a quarter. And for the visual demonstration, also had it in the collab. I pasted here, and you'll see the element and the window. The window is a sliding window, and each element, it belongs to multiple windows. Here, the first one belongs to 3 windows, and the second one belongs to actually also 3. Nope. And finally, the session windows. I pasted the description here. Maybe we don't want to regulate regular window, but instead we have the window reflect the period of where activity happened. Session allows us to create those kind of windows. We know how to specify a gap size in seconds, which is the maximum number of seconds of inactivity to close a session window. So similarly, I have the code below and I execute it. So now the window into have sessions, and the session only has one parameter, that is gap size. When the same element, we'll see how it goes. I also paste the demonstration here. And essentially the windows, the elements are grouped into these sessions, and each session can have single element if within the period of gap size it does not see another one, then this window just ends. And then here we have this element, and we still see in upcoming elements that has timestamp smaller than the gap size, then these elements are in the same windows. And this is how the session window works. So this is a basic demonstration. And now we go to another one that is a real use case, this streaming taxi rider, which is a very good example to demonstrate the windows. So again, I use this Dataflow notebook, and if you are not within a GCP environment, you will first need some Google Cloud CLI, some command line tool, and to interact with the public PubSub resource. So we first import something, set up the pipelines, and this IB is interactive runner. So being Python SDK provides an interactive runner that makes it convenient to use in a notebook environment. And we create a pipeline that run with the interactive runner and read the data from PubSub. This is just we define the pipeline and get a P collection. We haven't run the pipeline yet. And if we use this interactive runner, we can show the data in real time. We'll see here. To use it very simple, just use interactive runner show, and it will. You'll see the entries are increasing because this is a streaming source, and the incoming streaming data never ends. And basically, this is what the data looks like. It's a row and has a schema like this: a rider ID and some pointer, the latitude, the longitude, and importantly, there is a timestamp associated with each element, and there is a meter reading for this ride. And this is some real-time data. And what we do first is group this data into a window using a sliding window of, I think it's 10-second duration and 1 second interval between each slide. And we'll see how it goes. We can okay. This we can show the live data after we put them into Windows. And no, it prints a window. First, we'll see the pen is still pen 0 because we have not yet filed it. We do not use a group by key or something. So it's not filed yet. All the pen is pen 0 yet. And we can see it divided into some windows. It's not obvious here, but it's more obvious here. And each color is one window and is in some slided manner. And some graph. If you are interested, you can go this into more detail. And I just do an overview. And then we do some processing. That is, we first extract the one field called a meter increment from our data, and then summed all element by window. Use this combine globally sum. That will sum the element within the same window. And now we show the result. And it now propagates as we run the pipeline because it's a streaming pipeline. Alternatively, or in production, we always write it to something instead of just show it in the notebook. And we can also use write to PubSub. Yeah, this is a basic use case of the streaming pipeline with window. Yeah, thanks. That's the end of the demo.